Aerospace Propulsion Lecture Series. Myself, Dr.Praveen Kumar Balguri, Associate Professor of Department of Aeronautical Engineering with Institute of Aeronautical Engineering. In this lecture, we will learn the classification of gas turbine engines, and in detail we'll learn different types of turbojet engine. Gas turbines are classified into many types based on their components like compressor and turbine, and based on the way the air is passing through the engine. Based on these factors, gas turbine engines are classified into many types. Majorly, they are classified into these four types, that is turbojet, turbofan, turboprop engine, and turboshaft engine. These four also based on different mechanisms, like turbojet is a basic simple engine where turbofan would be included, and turboprop propeller is included here, and turboshaft, the energy would be transferred through the shaft, and we will discuss one by one. Turbojet engines were the first type of jet engine to power the aircraft as early as 1940s. A turbojet engine is an engine which produces all of its thrust by ejecting high energy streams through the nozzle, right? So in turbojet engine, all of its thrust is produced by ejecting high energy gases through the nozzle. This engine changed completely the air transportation. It greatly reduced the cost of air travel and increased the safety, and this engine enabled faster speeds, and the turbojet engine has higher thrust per unit weight compared with piston driven engines, which led directly increase in range and increased payload, and at the minimal cost. And military fighter aircrafts and fast business jet aircrafts uses turbojet engines. And these are the major components of turbojet engine: inlet and compressor, that is compression section, and combustion chambers, and then turbines, and then exhaust section. These are the major components of turbojet engine. Air enters to the engine through inlet, and air would be compressed to approximately 3 to 12 times of its original pressure by the compressor, and then it would be directed to combustion chambers where the fuel would be added and combustion takes place. Through the combustion process, temperature rises and energy would be added to the combustion exhaust, and this combustion exhaust would pass through the turbine. Turbine extract part of energy from this exhaust flow, that is, this energy would be converted to mechanical energy to run the compressors and other accessories, and remaining high energy stream would be passed through the nozzle. Nozzle converts this high temperature, high pressure gases into high velocity stream. Thus, turbojet engine produces necessary thrust. If the compressor and turbine are efficient, and the pressure at the turbine exhaust would be high, which will improve the thrust. And turbojet engines further may be classified as single spool or double spool engines, that is turbojet with single spool, turbojet dual spool, and maybe further subdivided into centrifugal and axial compressor types, that is based on the compressor type. Turbojet with centrifugal compressor, turbojet with axial compressor, like this. In this figure we can see simple turbojet with centrifugal compressor, and here is an inlet, and this is a centrifugal compressor, and these are then the flow would be compressed through the compressor, and then flow would be directed to the sent to the combustion chambers. These are the combustion chambers, and fuel would be injected to the combustion chamber. Then combustion takes place. This combustion products would be sent to the turbine and then pass through the exhaust where thrust is produced. Like nozzle converts this high pressure exhaust gas into high velocity gas. This thrust is produced here. And in this figure we can see a simple turbojet with single spool axial flow, that is single spool turbojet engine, and double spool or dual spool turbojet engine. Spool is an engineering shorthand of compressor and high pressure turbine connected with shaft. That means spool is a word which represents this set of components, that is high pressure turbine and compressor connected by shaft. Single spool means single set of these components. Dual spool means two sets of compressor turbine combinations. Right here in this we can see in the first diagram, here it is a single spool axial flow turbojet where compressor would be run by only by high pressure turbine. This is a single spool, and they are, of course, they are connected by shaft, right? And in the dual spool turbojet engine, here we can observe two sets of compressor and two sets of turbine. Here high pressure compressor would be run by high pressure turbine. High pressure compressor would be driven by high pressure turbine, and they would be connected by one shaft. And low pressure compressor would be driven by low pressure turbine. They also would be connected by separate shaft. If these two shafts are concentric shafts, means one shaft inside the would be adjusted inside the other shaft. And when you compare with these two, actually single spool design is a simple one. Dual spool design is little complex because number of moving components are increasing, so complexity increases. So performance wise, it may be dual spool compressor engines are good, but there is a there would be little risky. Increased weight, increased complexity also will be there. They are not as reliable as single spool engines. And turbojets may be classified based on afterburner, that is afterburning turbojet engine, and non-afterburning turbojet engine. Right? We have seen earlier turbojet based on spools and compressor, that is axial compressor, using axial compressor, then centrifugal compressor, then single spool turbojet, then dual spool turbojet. Now here we based on afterburning system, that is turbojet with afterburner, turbojet without afterburning. Afterburning is a method of increasing the thrust of jet engine for a short period of time in order to improve the aircraft takeoff, climb, combat performance, right? Actually, the power of jet engine could be improved by using large engines, but when we increase the size of the engine, frontal area increases, of course, which means drag increases and total weight increases. By considering these two factors alone, fuel consumption also would be increased, so it becomes more expensive. So afterburning is a best method to provide increased thrust for a short period of time. And the fuel in the fuel in turbine engine burns in excess amount of air, which means some excess amount of oxygen would be there to support further combustion. So this facilitates actually to inject additional fuel if required to initiate extended combustion after the turbine portion, right? So this is what this mechanism is called as afterburner. Actually, fighter aircrafts, when they are supposed to fly at higher speeds, like they want to achieve supersonic speeds, at the time of when it reaches the speed of sound, sudden increase in drag would be there. So they need a vehicle or pilot needs extra thrust to encounter this increased drag at speed of sound. By using afterburner, we can that additional required thrust could be provided actually. So see, when pilot turns on the afterburner, the fuel would be injected, additional fuel will be injected at the rear portion of the engine, that is after the turbine, and again combustion takes place. Additional amount of thrust would be increased. Actually, when from the combustion exhaust, actually turbine extracts part of energy and converts into mechanical energy to run the compressor. But by using afterburner, we are trying to whatever the energy is consumed, that can be given back by injecting additional amount of fuel. Here we can see a jet engine with afterburner. This is afterburner after the turbines. Up to this is a simple jet engine, right? Up to this is a simple jet engine, and now this is extended portion of the nozzle, where afterburner is included, right? We'll see the mechanism actually. See, as usual, the flow enters through the inlet and compressed in the compressor, then combustion takes, then sent to combustors, then combustion takes place, and part of the combustion energy will be converted to mechanical energy by turbine, and remaining exhaust. Actually, in this gas turbine engine combustion, additional amount of air would be there, additional amount of oxygen will be there generally. So to provide necessary thrust, additional amount of fuel could be injected through the afterburner. Here, through hoops, additional fuel will be injected here and burning takes place. Then further it would be passed through the nozzle, right? So whenever pilot is in need of additional thrust, only he's supposed to turn on the afterburner. And when he turns off the afterburner, the engine works as the basic gas turbine engine. Otherwise, if he or she, the pilot uses continuously for a long time afterburner, then he would be run short of fuel before completing the mission. So whenever it is required, maybe in combat applications or takeoff or climb, whenever they are in need of high thrust, then only afterburner supposed to be turned on, and immediately after that afterburner is supposed to be turned off. And here in this bottom figure, we can see the different. It is divided into different segments to understand the flow. Actually, flow 0 is a free stream flow condition, and 1 is entrance of the inlet. Then 2 is exit of the inlet and entrance of the compressor, and 3 is exit of the compressor and entrance of the combustion chamber. Then 4 is end of the combustion and entrance of the turbine, and 5th one is immediately after the turbine, that exhaust of the turbine, and 6th one is before afterburner. And here we can see the afterburner fuel injection mechanism here. And 7th location is that is immediately after the afterburner. Again, combustion takes place here. That is immediately after the afterburner, exhaust of the afterburner. Then 8 is exhaust of the whole turbine, gas turbine engine. That is at the exit of the nozzle. Here, by this we can clearly understand total mechanism with the afterburner. We'll see the advantages and disadvantages of turbojet engine. And turbojets are actually simple design and less low frontal area, so less drag, and they are suitable for long distances, flights at higher speeds and altitudes, and lower weight per unit thrust at design speed and altitude. And we'll see disadvantages also. We have seen that they are relatively simple design. Actually, advantage of turbojet engines are relatively simple design when you are comparing with other types of gas turbine engines. And some disadvantages are takeoff roll is longer, so requires longer runway, and they are loud also. Turbojet engines are little louder. Actually, they are loud and uneconomical on short distance flights, and lower thrust and propulsive efficiency at lower speeds. Lower thrust and propulsive efficiency at lower speeds. These are the advantages and disadvantages of turbojet engine. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.